Hi viewers, welcome to Lama Solution. Today we are going to see about grid connected and island and mode operation of microgrid. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification of the upcoming videos. This is the simulink model we developed for that testing of microgrid in grid connected mode and island and mode operation. The microgrid consists of wind energy systems, then PV power generation and battery storage and also inverter and then AC load as well as DC load. And finally this system is going to be connected via grid system. Here you can see that this is a wind energy system. The wind energy system consists of a wind turbine and PMSG and then rectifier and then have boost converter. This boost converter used for extract the maximum power from the wind energy conversion system based on that MPPT. So here we are using a P and MPPT to extract the maximum power from this wind turbine and the wind generator. And then the output of this boost converter connected to the DC bus, and DC bus voltage here we are going to maintain at 400 volt. The rating of the wind turbine generator is around nearly 2.8 kilowatt. That means here you can see the 2.5 e power 3, that means 2.5 kilowatt divided by 0.9, that means 2.5 e power 3 divided by 0.9 around 2.77, right? 2.78 kilowatt. It can generate maximum 2.7 kilowatt at a rated condition, that means 12 meter per second. And then this power generation can be changed based upon that wind speed. That means it will be changed according to wind speed. Here we created that wind speed. Initially it will be maintained at 12 meter per second. After 2 seconds, right, it going to be maintained at 10.8 meter per second. The power generation from that wind energy system going to be very depends upon this wind speed of the environment. Next you have to see about the solar PV system. This is solar PV system. Here we are using solar PV system around 2 kilowatts at the standard irradiation and temperature condition. The maximum power is around 2002 watts. Operating voltage is 245.6 volt. And then is going to be connected to the DC bus via this boost converter. And this boost converter going to be controlled by means of this incremental conductance MPPT. So you have to measure the voltage and current of the PV panel, and it going to be processed via incremental conductance MPPT. It going to be generate the pulse. It going to be generated in the duty cycle. The duty cycle is going to be processed via PWM generator. So this PWM generator will generate the pulse for this boost converter for extracting the maximum power from the PV panel. It depends upon irradiation and temperature. So PV panel peak power going to be very depends upon irradiation and temperature. And here we are using DC load. Here I am going to make the DC load power which is equal to 1000 watts. Here we are going to maintain DC bus voltage is 400 volt. So I am going to use DC load around 1000 watts. Next you have to see about the battery system detail. Here we are using the battery is 12 into 20, 22 volt battery, and then rating of the battery is 48 Ah, and charge of the battery here is 50, and it going to be connected to the DC bus via this bidirectional converter, and this bidirectional converter controlled by means of voltage controller. Here you need to measure the DC bus voltage, and it going to be combined with the 400 volt, and then it going to be processed via PA controller. It will generate a duty cycle. It going to be processed via PWM generator. It will generate the pulse. This pulse going to be controlled this IGBT, this two IGBT, not to maintain the DC bus voltage around 400 volt. Next you have to see about grid inverter and load system. This is inverter, single phase inverter, and then this is this LCL filter, and here we have two loads. Here we are using load, one is 1000 watts, another load will be 1400 watts. Total load will be 2400 watts. Initially load will be operated at 1000 watts. After 2 seconds this load will be connected. Total load will be changed to 2400 watts. And then here we have grid system. The grid system operated at 230 volt, that means 325 volt per peak, 50 Hz frequency. And then this grid will be connected to this system or disconnected from the system by means of this control. When we have to place one here, right, then the grid system will be connected to the system. That means the breaker will be closed during that condition. When we are putting 0 here means that circuit breaker will be open. That means the system, then this grid system will be disconnected from the system. Then the whole microgrid will be operated in the islanded mode. This is the control of islanded mode. That means control of inverter in islanded mode. For that we need to measure the voltage of the load. Before that you have to generate the and sine cosine waveform. We have to generate the reference sine wave and cosine wave, and here you have to measure the actual and the load voltage. Here we have A and neutral voltage. That means phase voltage and neutral voltage will be converted into dq form. Here you can see that you have to measure the current of the, that means load current or inverter current. That current going to be compared with the reference current here. Before that, in order to get that reference current, the dq voltage should be converted into that reference current. For that, we are going to generate reference voltage by means of this sine cosine waveform. By using the sine cosine waveform, we have to generate the d q reference for the voltage controller. The d reference q reference going to be used to compare this actual d and q of the load voltage. So it going to be processed via voltage via controller. It will be generate the, that means two control output. One is the form of d axis, another form of q axis. So that should be converted into AB form, that means phase and neutral concept, by using dq to ABC conversion formula. And they have to take only this phase component that going to be combined with the load current, and then going to be processed by a PI controller. So this PI controller will be generate the modulating signal for generating the pulse for this. This is islanded mode operation. Islanded mode operation, that control that impulse when we generate that for that inverter based upon voltage of the load and the current of the load. So next you have to discuss about the inverter control, that will grid connected mode control. Here we have that logic. Here we are going to, when you have to connect it to the grid, we have some agreement between grid and the microgrid. That agreement going to be created based on two parameter. So one is IPV and the SOC of the battery. We are measuring IPV. If IPV less than 0.5, the SOC of the battery is less than 10%, then we are getting the power from the grid. If solar PV current is more than 0.5 and SOC of the battery is more than 10, then we are going to send the power to the grid. So here we are sending 2 amps peak current for the grid, and during shortage of power we are getting power from the grid is around minus 10 amps. Okay, during grid connected mode, this 10 amps peak. When you order 2 amps, sending 2 amps peak means that means around 230 into 2 divided by 1.414. Around we are going to send around 326 watts to the grid. When we are getting power from the grid, we are getting power around 230 into 10 divided by 1.414 is around 1.63 kilowatt. That thing is decided based upon PV current and the SOC of the battery. So here also we are going to convert that this is reference current in magnitude. So that should be changed to sinusoidal. So in order to change sinusoidal, we are using PLL here. So we are measuring the grid voltage that going to be converted into omega t by using PLL, and then we are generating sine cosine waveform that when we multiplied with the reference that when we converted into sinusoidal form. Here you need to convert that the phase neutral into dq form by using that AB to dq transformation, and then it will be known as a dq reference q reference. So next you have to measure the actual grid current or inverter current, and then it going to be converted into dq by using transformation, and then this reference current dq reference current and then actual current when we compared and the process via PA current controller. This current PA controller will be generate the control voltage in the form of D and Q axis, that will going to be converted into dq to ABC form. It will generate the modulating signal. That means here we are going to convert dq to ABC, and we have to take only A quantity. This A coordinate nothing but a modulating signal. So this modulating signal used to for control the inverter during grid connected mode. And here from islanded mode control we are getting another modulating signal. Here we have to generate the pulse. For that we use one switch case based upon the islanded mode detection. When is this control signal is greater than or equal to 1, then the system should be grid connected mode. We have to allow this modulating signal for generating the pulse for inverter. If the control signal equal to 0, that means system operated at dilated mode, then you have to allow that control signal, that means modulating signal from the highlighted mode control. Based upon that control logic created, we are allowing that modulating signal for generating the pulse. Here we are building process via that modulating signal via pendulum generator. It will be generate the pulse for this inverter. So this inverter going to be operate according with the highlighted mode and grid connected mode in order to share the power. This is the overall operation of this grid connected highlighted mode operation of microgrid. So now we have to see about the result of the system. Now I'm going to operate the system in grid connected mode. Already I simulate this model. Here I'm going to simulate this model again. This is PV measurement. This PV voltage, PV current and the PV power. The PV power will be vary according with the irradiation, because here we set the irradiation initially 1000, after that comes to 500, after that it comes to 10 watts per meter square. Again it goes to 500 watts per meter square, and then 1000 watts per meter square for every 0.3 seconds. According with the irradiation, the PV power will be varying. Because of change in PV power, we can see that variation of battery, charging of battery, boost converter input power or rectifier power of the wind generation. Here we have power around 2.7 kilowatt. Right? This is the power generation from the wind. And then here you can see that battery voltage, battery current associated with the battery. Here you can see that the battery is charging mode. And here initially I told, right, that initial load is connected. Here is load is 1000 watts. You can see that this is load voltage, load current, and then load power. And here you can see that already told here this 1000 watts is connected in the DC load side. So this is DC bus voltage and DC load current. This is DC load power is maintained around 1000 watts. And here you can see that this is a grid voltage and grid current and the grid power. So from that you can see that this grid power is around because in grid connected mode, that means current we are getting from the microgrid as around 2 amps. Earlier told that is it can supply the power to the grid around only 327 watts, right? The 27 watts is taken from the microgrid to the AC load. The remaining power we are getting from the grid. We can see that the power will be around 700 watts. So 700 watts taken from the grid. The remaining 300 will be taken from the microgrid for the AC load. Then you can see that after 2 seconds, what will happen? The load of the AC load will be changed from 1000 to 2400. At same time, wind power speed is changed from 12 meter per second to 10.8 meter per second. Because of that, means power also going to be decrease. We will see that variation during that after 2 seconds here during the connected mode. So now you can see that because of variation of grid power due to irradiation, so here you can see that there is a charging variation in the battery. The battery power, the battery current, right, will be initially around minus 12 amps. After that it changed to minus 8 amps. This battery current changes, charging current depends upon that PV power, wind power. We wait for 2 seconds. Now we can see that AC load change from 1000 to 2400. And then here that wind speed change from 12 meter per second to 10.8. Because of that, the power will be, the power generation will be, wind will be reduced to around 1500. Because of that, what happened, the battery charging current is decreasing. And then you can see that the sharing of and the grid is around 2100, right? Because here 2400 is connected in the AC load. So we are getting 300 watts from the microgrid, and then remaining 2100 watts power is taken from the main grid. Here you can see the DC load maintained at 1000 watts. So this is operation of a microgrid in grid connected mode. So next I'm going to change the system with the islanded node. I am going to change this condition to 0, and then you will check the status of the system. Now you can see that because of change from grid connected mode to islanded mode, right? This is a variation of the system here, right? Now the power of the wind is around 1500, and then here the power of the PV is around, that means during that change from grid connected mode to islanded mode, right? So there is some transient occur in the system. After transient, and it will take 0.3 seconds to settle down to that maximum power. Now the maximum power is around 2000 here, 2000, and then here you can see that the AC load, that means the load AC load is maintained at 2400, and then DC load is maintained at 1000 watts. Now battery comes to discharging mode, right? Because of the operation change from grid connected mode to islanded mode. Here you can see that the AC load continuously getting the power from the microgrid, and all the DC load is continually get the power from the microgrid. And here you can see that because the grid is disconnected from the system, so the grid power is going to zero. There is no current and voltage in the grid side. This operation of islanded mode of microgrid and grid connecting mode of the microgrid. Thanks for watching our videos. Kindly subscribe channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.